Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes 3rd edition, and we're doing problem number 2.26. I'll go ahead and read the problem statement. The density of a fluid is given by an empirical equation, then they give the equation, where rho is density in pounds mass per foot cubed, and P is pressure, pounds force per inch squared. Part A, what are the units of 70.5 and 8.27 times 10 to the minus 7? Well, let's write down the equation that they gave to us. Rho equals 70.5 exponent 8.27 times 10 to the minus 7 P for pressure. Okay, so something you have to know is exponents cannot have units. So this term inside right here has to be unitless, which means that we'll call this A. This number right here, this is A, and then this is P. So A times P has to be no units. Okay, that means if P is a pressure in pounds mass per square inch, then that means that A has to have units that are the reciprocal of that. Inches squared per pounds. Oh, it's force, it's not pounds mass. Pounds force per inch squared. Okay, so that's the unit of A, the part that's in the exponent. Now, we know what the densities units are, and therefore, in order for this expression, the full expression on the right-hand side, in order for this expression to have the same units as density, well, then 70.5 has to have the same units as density because the exponent term is unitless. Therefore, 70.5 has the same units as density, which is pounds mass per foot cubed. So that is the answer to part A. Okay, so let's move on to part B. Calculate the density in grams per cubic centimeter for a pressure of 9 times 10 to the 6 newtons per meter squared, or pascals. Okay, this is very similar to problem 2.25, which we just did. So if you want to go back to episode number 25, you can watch that. There's some more explanation. This one I'll just kind of go through a little faster with a little less explanation than I did on that last one. So to begin with, we have newtons. We need to convert those. Which equals pascals. And how many pascals are in a PSI? There are 6, 8, 9, 4.76 pascals per PSI. And this equals 1.31 times 10 to the 3 PSI. And that means pounds per squared inch. Pounds force per squared inch, PSI. We're calculating the density with this. So we put the PSI into our equation from up top, and we calculate what the density is. 70.58 pounds mass per foot cubed. Now we need to convert the density into what? Grams per cubic centimeter. So 70.58 pounds mass per cubed, 4 53.6 grams per pound mass. There are 30.48 centimeters per foot. And this equals 1.131, except for we started significant figures is 3 significant figures, so 1.13 grams per centimeter cubed. That's the answer to part B. So now we're on part C. Derive a formula for density in grams per centimeter cubed as a function of pounds, pascals. Check your results using the solution of part B. Okay, so doing the same thing we did in the last episode. We need to convert our equation, which is rho equals 70.5, 8.27 times 10 to the minus 7 p. Okay, so we need to convert, I'll call this A, and I'll call this B. And we need to convert those into different units, because right now they're in the units of reciprocal PSI and density. So let's just convert those. So A currently equals 8.27 times 10 to the minus 7, and that's in reciprocal PSI, so pounds force inch squared. And then we're converting this into pascals. So our conversion up here was, there are PSI, there are 6,894.76 pascals and a PSI. So A equals 1.199 4 times 10 to the minus 10 pascals, reciprocal pascals. And then B equals 70.5 pounds mass feet cubed. And this equals 1.1293 grams per centimeter cubed. Okay. I'm putting a bracket around those. Okay, so now we know what A and B are, and we have our equation. So let's just plug in our numbers and see if we get the same answer as we did in part B. 1.13 grams per centimeter cubed. Great. That's it for problem number 2.26. Thanks for joining me. If you saw any errors that I made in the problem, put it in the comments, let me know, and I'll try and get a correction in here. As well, if there's another problem that you'd like me to do, any requests from this book, I can work on getting the requests written up and potentially help you guys on a problem that you need help with. Thanks. Bye.